Okay, let's take a look at solutions going between different concentrations. By popular demand, I was asked to go over a problem like this in a video setting to give further explanation. And the key to these problems are number one, knowing the definition of your various concentrations. So you have to know how your concentrations are defined. That's number one. Number two is you have to know the relationship between grams and moles. You have to know the relationship between moles and grams. And you have to know the relationship between volume and density. And you have to know the relationship between mass and density. So these are the key elements that you need to understand when you work these type problems. If you understand the definition of the concentrations, how they are defined, if you know how to use your molar mass to go between grams and moles, and you know how to use your density to get the mass or the volume of a solution, half your work is already done. So let's look at number one, part A. So a solution is prepared by dissolving 50.4 grams of sucrose in 0.332 kilograms of water. The final volume of the solution is 355 milliliters. So this 50.4 grams is your solute. Your solute is the part of the solution to be dissolved. And you have this mass of water. This is going to be your solvent. The solvent dissolves the solute. So together, your solution is equal to the solute plus the solvent. That's what makes up a solution. So when you understand this definition, working the problems become much, much easier. Now, when you understand the definition of the solution, we need to understand how the concentrations are defined. So if we look at A, molarity. Molarity is designated by capital M, and it is moles of solute over volume of solution in liters. So, to get the molarity, I need to get the moles of the solute. but I was not given the moles of the solute, I was given the mass. So I have to take and convert the mass. So 50.4 grams of C12H22O11, and I want to convert that to moles. So in 1 mole of C12H22O11, we have 342.3 grams of C12H22O11. So when I do this operation of multiplication, or you could call it division, I wind up with 0.147 moles of C12H22O11. Now, I'm still not finished, because to get molarity, I need the volume of the solution. It told me in the problem that the volume of the solution in milliliters was 355. So I need that quantity in liters. So I need to convert 355 milliliters to liters. So in 1 milliliter, there's 10 to the minus 3 liters, and that is equal to 0.355 liters. That would cancel also. So I can calculate the molarity now and say that the number of moles is 0.147 mole of C12H22O11 divided by 0.355 liters. And when I divide those two numbers, I wind up with 0.414 moles per liter. So this is the molarity of the solution that contains 50.4 grams of sucrose with this volume. Now the molality is little m, and it is defined by moles of solute over kilograms of solvent. Well, we found our moles of solute here. So in the problem it told us, it gave us explicitly the mass of the solvent in kilograms. It will not always be in kilograms. Your mass of solvent in the problems, you may have to convert it to kilograms just to be on notice. So what we do is we divide the number of moles of solute, 0.147 moles of C12H22O11. Divide that by the kilograms of solvent, 0.332 kilograms of H2O. and that is equal to 0.443 moles per kilogram. So that is the molality of the solution. Percent by mass. Is equal to the mass of the solute divided by the mass of the solution multiplied by 100%. So we need the mass of the solute. Well, the mass of the solute was given in the problem in grams. This is our mass of solute in grams. So we can take that directly as 50.4 grams of C12 H22011. Now we need to divide by the mass of the solution. So as I stated, the solution is equal to the solute plus solvent. So to get the mass of the solution, I need the mass of the solute plus the mass of the solvent. Okay? I am using this notation for mass, not molarity. So, since we already have our mass of solute in grams, we're going to keep the unit of grams. So, the mass of the solute, this right here, is 50.4 grams. Plus we need the mass of the solvent in grams. So the mass of the solvent was given as 0.332 kilograms. So we need to convert that number to grams. So in 1 kilogram, we have 10 to the third grams. So the mass of the solvent becomes 332 grams of H2O. So that's 332 grams of H2O. So now we can determine the mass percent. You want to sum these in the denominator. That's why this is in parentheses. So you would divide the numerator by the sum of the denominator. And that winds up to become 0.13 rounded to 2. And we want to multiply that by 100%. So the percent by mass is actually 13.2%. So what that means is for every 13.2 grams of C12H22O11, there is 100 grams of 100 grams of solution. Okay. Now the last part is mole percent. So I'm going to erase a little bit of this so I can do the mole percent and mole fraction. Okay, so the mole fraction designated by chi so we can have chi of the solute. For this, we will need the moles of solute and solvent. So mole fraction mole fraction is designated by chi. So we can do chi of the solute, which is C12H22O11, is equal to N of C12H22O11 divided by N of C12H22O11 plus N of H2O. So this is the solute. This is the solvent. So when we plug those numbers in, we know that our solute is 0.147 moles C12H22O11. And we come to the denominator to add the solute again, 0.147 moles C12H22O11 plus the number of moles of water. Well, we were not given the moles of water. We were given a mass of water. So we have 0.332 kilograms of H20. So we need to go from kilograms to grams, and from grams to moles. So kilograms of H2O, grams of H2O, moles of H2O. So, kilograms, in 1 kilogram we have 10 to the third grams. Now we're in the unit of grams of water. So we need to go from grams to moles, and 1 mole of H20, you have 18.02 grams of H20. So that gives me a total of 18.4 moles of H2O. So my moles of solvent is this, and I will write 18.4 moles of H2O. Now I want to sum these in the denominator. When I sum those in the denominator, and I divide the numerator by the sum of the denominator, that's why this is in parentheses, I wind up with a mole fraction of solute 0.00793. So this is equal to chi of the solute, and the solute is C12H22O11. Now the mole percent would be simply multiplying this number by 100. So 0.00793 multiplied by 100% is equal to 0.793%. This is the mole percent. Okay. You could also calculate the mole fraction of the solvent, and you could say chi of H2O is equal to the number of moles of H2O. We found that to be 18.4 moles of H2O divided by 0.147 moles of solute plus 18.4 moles of solvent. And when you sum the denominator, divide the numerator by the sum of the denominator, you wind up with 0.99207. The mole percent would be this number multiplied by 100, and that would be 99.207%. So recall that the mole fraction of the solute plus the mole fraction of the solvent is equal to 1. So this is true in that chi of C12H22O11 plus chi of H2O is approximately 1. So go through this problem and see, can you work it without looking at the video and getting the correct answers. This is a very good test question.